Good day to all. Today we are going to see about the control of DC drives. First of all, we are going to see the introduction. The most common form of that variable speed DC drive is based on the control of armature voltage. Then the speed of the DC motor has to be controlled from an AC or DC sources. More commonly, control rectifier is used to supply the motor armature. The phase locked loop control techniques are employed in some DC drives to provide precise speed control. See the types of configurations. There are two main types in that DC motors: series excited DC motors and separately excited DC motors. The series excited DC motors, as a series motors are traditionally employed for transaction applications. Then the separately excited DC motors, at present the separately excited DC motors controlled by a thyristor converters are most widely used the motor drive system in that industry. See, the main classification of DC drives is single phase drives, three phase drives, and chopper drives. These are the main classification of DC drives. We will going to see one by one deeply. First of all, we will going to see single phase and three phase DC drives. Already we know what is that single phase. What is three phase? See, in home itself we will know about the single phase. Most of the home we are using for a single phase. Single phase means positive and negative. If it is we have to connect to the ground, means ground connection will also be there. If it is a three phase power supply, means that is R, Y, B. Some of the home they will put these three phases. As we know already, the R means red and Y means yellow, B means blue. Most of the industries, maximum industry, they are using this three phase connection only. This single phase connection have some 0 to 230 or 220 volt, whereas in that RYB three phase means 0 to 440 volt. This RYB means the wire is in these three colors, in red colors and yellow colors and blue colors, like that. These are all the main concept of that single phase and three phase power supply. Here the converter used for a particular application depends upon the such factors as a supply available in single phase or three phase. See, converter here it's used to whether it going to be used in that single phase or one phase, we can say, as well as in that three phase. Then DC chopper drives. See, what is that chopper? Chopper is nothing but convert the fixed to variable. That is the main concept of this just chopper. So we have to give the fixed to variable of that DC. It is called a DC chopper. Here we will going to about the DC job drives. To control the speed of DC motors, we can control the motor terminal voltages. The chopper output voltage is proportional to the chopper switching frequency. and its duty cycle. So the magnitude of voltage entering the terminal motors can be adjusted, so the motor speed. Control of the DC motor's speed by a chopper is required where the supply is DC. See here, the control of DC motor speed by a chopper. Controlling the DC motor's speed by a chopper is required where the supply is a DC. If it is a supply is in DC, we have to control over with the help of this chopper as from a battery, or if it is in AC voltage that already has been rectified to a DC voltage. Then the most important application of these choppers are in the speed control of DC motors, which is used in industrial or in transaction drives. Then DC choppers are used for the control of DC motors. Why? Because the number of advantages in that controlling with the chopper, we have a high efficiency and flexibility in control, and it is lightweight, small size also, quick response also. These are all the main advantages why we are going for that control via chopper. Then chopper control DC drive has also application in servos in battery operated vehicles such as forklift, trolls, so on. Then we'll move about that PLL control of DC drives. What is PLL? It is nothing but phase locked loop method, that is called PLL. In this PLL method, the motor speed is converted to a digital pulse train, which is synchronized with the reference digital pulse train. In this way, by locking onto a reference frequency, precise control of a motor speed is achieved. Now you can see the diagram of this PLL control device. Here you can see first one is phase detector and LPF. LPF is nothing but, already we know that LPF means low pass filter. It is one of the type of the filter. So after that phase detector will have a LPF, that is the low pass filter in that phase lock loop. After that the converter is used to convert, right? Then it will connected with the DC motors. This output will again with the feedback of speed encoder. This will go to the phase detector. This is the main concept of PLL control of DC drives. Now you will compare with this DC chopper. As I said before, chopper is used to convert the fixed DC into variable DC. And also advantages also, it has a high efficiency. High efficiency also, it is a main advantage. Whereas in the phase lock loop, you will see it just motor speed is converted to digital pulse train. Here it is used in different application. Whereas in that previously in chopper we'll have only fixed to variable there, but here we'll have a convert of motor speed. Yes, is convert with the digital pulse train. This digital pulse we are going to use, which is synchronized with the reference digital pulse train, and this is that particular circuit for that phase lock loop. that phase detector and the LPF and converter DC motors will have a input over on here, then the output will feed back to the speed encoder. These are all about the PLL control of DC drives. Thank you.